Yes, Dumelang. Hello, how are you? Sanmalang. Assalamu alaikum. Welcome back. Like I said, this is actually the first example that I'm gonna be attempting. Yeah, the first tutorial that I'm gonna be attempting. So what's needed of us here, we here to determine the minimum shaft diameter, right? Based on the ASME equation. Now the ASME equation, what does it consist of? It has the maximum moment, right? The maximum moment on the shaft, and this is the endurance stress, right? And this is the torque, and this is the yield stress, right? Now, okay, this is the factor of safety, and it's the factor of safety, right? Now, in most questions, like in most tutorials, in most questions, what you're given, right, is the endurance stress. You'll be given, yes, and the yield stress, right? Well, sometimes they might give you the yield stress and the ultimate stress. Okay, let me try to write these things down and just not just talk about it. Right, most questions, what you're given is the yield stress, right? And you're also given the endurance stress, sometimes stress limit, doesn't matter, right? Or if you're not given the endurance stress, then you'll be given the ultimate yield, ultimate tensile stress, right? It's called ultimate tensile stress, right? So these two you will be given 1, 2. That's easy. What's the main concern is the maximum moment on the shaft, right? The torque, right? Okay. Now looking at this question, let's just start by writing what are we given, right? And on this question we're given the ultimate. Okay, let me just what we given. I have this old friend, his name was Given. I don't know why I'm thinking about him. Yeah, but then we're given, what are we given? On this question we're given the ultimate stress, which is ultimate tensile stress, which is 1000 megapascal, right? And then we're given the yield stress, which is how many? 770 megapascal, right? And the Brinell hardness approximately 200 and blah blah, right? The radius of the fillets at the gear and the pulley shoulders is 3 millimeters, right? Those ones don't concern yourself with them, because you only want to concern yourself with them when you're going to calculate the endurance stress. But now I want the main focus is the moment and the torque, the maximum bending moment and the torque, right? Now let's go back to our statement. The power to be transmitted is 8 kilowatts. Power is 8 kilowatts, right? At 900 rpm, revolutions per minute. The speed is 900 rpm, right? The pitch cycle diameter of 20-degree pressure angle, right? Now we're given the pressure angle is close to 20 degrees, right? 20-degree pressure angle, spare gear, right, is 192 millimeters, and the pulley diameter is 250 millimeters. We're given the diameter of the gear and also the diameter of the pulley. Bro, this is a 3 hours question, so bear with me. But then I'm sure all my engineering fellas know this is nothing to us. So we're given the diameter of the gear, right? The spare gear is 192 millimeters. I like to write my things in meters, so it's 0.192 meter. The diameter of the pulley is 250 millimeters, which is 0.25 meter, right? And the masses of the gears and the gear and the pulley are 8 and 10 kilograms respectively, right? Mass of the gear, mass of the pulley, right? So that means the weight is going to be considered in this question. So we have 8 kilogram, and here we have 10 kilogram. And let's go. The ratio of belt tensions should be taken as 2.5. That means T1 over T2 is equal to 2.5. I talked about this in my last video, so if you didn't watch it, go back and watch it, then you'll know what we're talking about. My profile keys are used to transmit torque through the gear and pulley. A shaft nominal reliability of 90% is desired here, and then a nominal diameter of 32 can be assumed for the shaft. Okay, right. So what is the main concern here? What are we trying to find? The maximum bending moment and the torque, right? Okay, all right. Now let's look at our question. The shaft itself. Let's look at this shaft, right? We have bearing A. Let me just A, B, C, D. We are bearing at A, we are bearing at C, right? And then we have a gear here, B, gear at B. There's a pinion, there's a gear, so it's one gear set. I have a gear at B, and then we have a pulley at D, right? And then this pulley, it has two tensions. The tensions are pulling on the Z direction, because there's X, there's Y, there's Z, X, right? I hope you understand me, right? So what are we to find? The maximum bending moment and the torque acting on this shaft, right? And also don't forget, we're given the masses of both the pulley and the gear. That means we have to consider weight, right? Okay, sharp. Now let's solve this problem. Let's solve this problemo, right? But then yeah, this is real nigga stuff, right? Okay, number one. Let's focus on the gear first. Let's focus on the gear first. And also this power and the speed is of both the gear and the pulley. That means the shaft, both the pulley and the gear, they are moving at the same torque, right? Okay, I put that on. I got that out of the way. So first things first, let's find the torque. Torque, simple, easy. Nobody doesn't. I feel like every engineering student knows this. Torque is equal to 60 P divided by 2 pi N. Why? This is the torque of the, let me just say the torque of the shaft, but then, okay, torque of the shaft is equal to 60 multiply whatever power is 8 kilowatts. 8 times 10 3, right? Divided by our speed, which is 2 pi N, 900, right? 900. And then what is our torque? Calculator. Yeah, they make things easier for us. We're using calculators now. 68. No, bro. 60. Bro, you know, before you write a test, make sure that your calculator is not in radians, because hey, you'll see flames, bro. 8 times 10 3, 2 pi N, which is 900. Right? That means my torque is 84.88 Newton meters. Right? That's my torque. Now let's look at the gear. We're gonna solve this first and then we'll go to the pulley. Right, let's look at the gear. What is happening on the gear? On the gear we have two forces acting on it. Like I said in my last video, I talked about this. There's a tangential force and there's a radial force. So there's two forces acting on this. You have to find these two forces, right? And in my last video, what did I say? In my last video I said the tangential force is equals to the torque over the r, which is the radius, right? So it's gonna be the torque we already found it is 84.88, right? And then the radius of the gear. Here we're given the diameter of the gear, right? Diameter of the gear is 0.192. So it's gonna be 0.192 divided by 2, right? Half of that, 0.192 divided by 2, which is 0.096, right? Then we find our tangential load. 84.88 over 0.096, which is 884.167 Newton. This is a force, so it's measured in Newton, right? Now we're done with our tangential load. Now let's find our radial load. And like I said, everything's leading back I'm taking everything back from my last video. So if you didn't watch it, go back and watch it, and then you'll know what I'm talking about, right? We found number 1 and then number 2, radial load. Fr is equals to Ft tan, which is my pressure, tan my pressure angle, right? Okay, so it's gonna be 884.167 tan. What is our pressure angle? Our pressure angle here we're given is 20, right? Tan 20, and that is 884.167 tan 20 is 31.81 Newton, right? Nice. And also we're given the weight of we're given the mass, not the weight. Okay, let's calculate the weight of the gear 2. Number 3, the weight of the gear. W is equal to mg. Take the mass of the gear is given is 8 kilograms. 8 multiplied the gravitational acceleration is 9.81. Alright, so the weight acting on the gear is the weight acting on the shaft due to the gear is 8 multiplied by 9.81 is 78.48 Newton. So there's 3 forces: tangential, the radial, and the weight itself, right? We're done with the gear. We're done with the gear. You see why I'm using papers? Because when I'm writing with a pen marker, it like the ink is coming down. The ink is transferring itself into the next page. That's why I'm using papers, right? Okay, now we're done with the gear, right? We're done with the gear. Number 2, let's focus on the pulley. Pulley. Let's focus on the pulley. Like I said, the torque that I found is of the shaft. So the torque is acting, the same torque that is acting on the shaft is the same torque that is acting on the gear, and also the same torque that is acting on the shaft, right? On the pulley, I mean, right? And then when we're talking about a pulley, the torque is equals to T1 minus T2, right, multiplied by the radius of the pulley, right? And then we have what? We have the torque already, is 84.88 is equals to T1 minus T2 multiplied by the radius of the pulley. Here we're given the diameter of the pulley, so we divide that by 2. 0.25 divided by 2 is 0.125. 0.125. Hey, we got it. Okay, right now I'm trying to find both the tension, the T1 and the T2, right? So I'm just gonna divide this and simultaneous. Oh, grade 10, yeah, simultaneous. So it's gonna be T1 minus T2 is close to 84.88 divided by 0.125. T1 minus T2 is equals to 84.88. 0.125 is equals to 679.04. That's my equation 1. And then my equation 2, remember, we're given the ratio. Don't forget this. So that means T1 is equals to 2.5 T2. That's my equation 2. Right? And then simultaneous. That's now with simultaneously. Right? So I'm gonna take this one and I'm gonna substitute in here. So that means 2.5 T2 minus T2 is equals to 679.04. Right? That means T2 is equals to 679.04 over n.5. If you've done Africans, you know that one is yen. If you didn't do Africans, that means you were born yesterday, my boy. I'm joking. Even I didn't do Africans. Okay, 679.05 divided by 1.5. That is our T2. 452.69 Newton. Then we can easily find T1. T1 is 2.5 multiplied by that. Multiplied by 452.69. That means T1 is equals to multiplied by 2.5. 1131.73 Newton. All right, we found T1, the tension, the tightest and the slackest. Found T1 and found T2. Yeah, we're getting there. Because we lose this like yeah, so we're getting there, bro. We're getting there. Okay, and we're here. Now all this is confusing me now. See all this fucking I'm not allowed to curse, sorry. See all this paper that are confusing me now. Right? We found the tension. Oh, let me find the weight. Number 2, let me find the weight of the pulley itself. Weight of the pulley is just mg, right? Bro, come on, mg. So it's gonna be the mass of the pulley we're given is 10, then multiplied by the acceleration 9.81, right? And the weight of the pulley is, if you don't know this by head, you're stupid. 98.1 98.1 Newton. But then I don't want to make mistakes, right? I'm just gonna punch it in. 10 multiplied by 9.81. 0.81, you know. Yeah. Yes, mashallah. 98.1 Newton, right? So looking at our question, I think we found almost everything, right? Now it's time to draw the shear stress diagram and in both direction and check the bending moments. Right? Yeah. Okay. So that we're gonna do that in our next video. Yeah, we're gonna do that in our next video. So bear with me. Like I said, this is long, but then we'll get in there. Next video.